So we'll start here. Come on. There we go. How about this? All right. Okay. So greetings, scholars. Let me see. Hope everyone had a great weekend and you enjoyed your weekend. You were able to get some rest and get some work done and have some fun. I definitely encourage balance. Do what you need to do. As far as desires and necessities. Let me see. So we are at the top of week 6, right? So we had exam 1 about a week and a half ago. It was due last week, whatever. So this is week 6. We're just gonna go into the next section. So whatever section we did last week, we're just doing the next section, and then we have next week's section, and then after that will be exam 2, right? So this course is College Algebra 1 with online lab. So that means not only are we responsible for our material that's on Pearson. Again, I'm just a friendly reminder. Let's make sure that we're also doing our lab component. This class has a lab component. You should be in contact with, in communication with Dr. Lamar. She's the facilitator for the lab, and basically just follow her instructions. Whatever she says you need to do, that's what we expect you to do. And then when it comes around midterm and final, she'll give me a grade for each student, and I'm going to take that grade, scale it to 10% of your overall grade, and incorporate that into the grades. Hopefully you all have, for those that needed to, you were able to use your book vouchers in the bookstore. I haven't got a confirmation whether anybody was successfully able to do that yet or not, but I know that some students were trying to use book vouchers, and then in the past, you were able to use book vouchers at the Morehouse bookstore to purchase a My Math Lab access code, right? And then that's all that you really need is the access code, a working access code that you can actually use. You gain full access, and then you can do everything you need to do as far as our class is concerned. As usual, this is remote asynchronous. So if you're in the Zoom call now, that means you've gotten your attendance credit. You're not obligated to stay. Also, if you have questions, comments, or concerns, feel free to unmute yourself to get my attention or type in the chat. The original intent is for class time to be like a Q&A study session, office hours kind of deal. I just fill it with the lecture and homework just to fill the dead air. So if you want to talk about homework or a quiz or something like that, or even the exam, we can. But otherwise, if there aren't burning questions, I probably should not have used that phrase. That's my usual phrase at the end of the class. So you might feel like it's time to go. But no, we're going to hop into the next section, right? So let's go like this. Uh-oh, we're missing stuff. Why is it blank? Let's try that again. Let's go back. This one, right? Okay, that's better. All right. So we're continuing chapter 1, graphs and functions. And so today we're starting with section 1.5, transformation of functions, right? So I think the last time we touched on, now together live, we didn't go through all the basic functions, but we kind of touched on some together, right? My pre-recorded lectures have the entire section, right? We just don't have enough time together because ain't nobody got time for that, right? We don't have time together to go through the whole section. So that's why I made the pre-recorded lectures. That way we can be respectful of each other's time and still do what we need to do. But just to kind of a quick recap of library of basic functions, like the first one is you have like the constant function, y equals some number. It's just going to be a flat horizontal line. Y equals x is identity. So it's that diagonal line. You got y equals x squared, which is a U-shaped curve, which is a parabola. Y equals x cubed is an S-shaped curve. So these are all basic graphs that we're going to be manipulating, right? So to further this discussion on graphing, we started last week with just a list of basic functions. Some others were like the square root of x. I don't know that we kind of talked about this together live, but it's definitely in my pre-recorded lecture where square root of x, the way I remember that one is going to be, the image looks like the top half of a sideways parabola. So if you take that U-shaped curve, turn it on the side, cut it in half horizontally, square root of x looks like the top half of a sideways parabola, right? So that's the base shape. And then we're going to start moving that shape around. Let me see some others. Absolute value of x is a v. You may have come across one that's called the greatest integer function. We call that a step function. It looks like, because it looks like steps on a staircase. We'll touch on that if it pops up. Those are the main ones. There are a few others, but those are the main ones. And then I know at some point in the last section in the pre-recorded video, we talked about like domain and range of each of those, and like whether it's increasing, decreasing, or constant over what intervals. You know, it was jam-packed. All right, it's jam-packed. So hopefully you were able to catch the nuances there that you needed, and you know, you're positioning yourself for success. So today with section 1.5, transformation of functions, a few objectives. We like to define transformations of graphs. We like to use vertical or horizontal shifts to graph functions, use reflections to graph functions, and use sketching or stretching or compressing to graph functions. All right. So these are some of the objectives for today. And I'll check Zoom again at about 9:15 for the people that's coming in late. I just don't want to delay the class going back and forth trying to take attendance. But we'll get people that get into this in the waiting room if they're there. Anybody want to read this? I'll give you a few seconds if there's a volunteer that wants to read it. I will read it. Okay. So here we have what? Transformations. If a new function is formed by performing certain operations on a given function f, then the graph of the new function is called a transformation of the graph of f, right? So starting with one of those basic graphs that we have from section 1.4, now we're going to start moving those around, stretching and compressing, flipping, doing different manipulations to generate graphs. So in this example, this is on graphing vertical shifts. Let f of x be the absolute value of x, g of x be the absolute value of x plus 2, and h of x be the absolute value of x minus 3. Sketch the graph of these functions on the same coordinate plane. Describe how the graphs of g and h relate to the graph of f. Okay. I think I'm going to rely on my prepared notes just because it's kind of tedious to write all this out. So, but basically with something like this, to introduce this idea, we're going to make a table, right? We're going to choose several values of x, probably like when x is 0, plus or minus 1, plus or minus 2, and plus or minus 3. And then find the corresponding y's or the corresponding outputs for each of these three functions and put them on the same graph. And then we're going to plot the points and graph these three together and see, okay, starting with the base function of absolute value of x, which should be a v with the vertex at the origin. And then we're going to see how when we add a positive number outside our basic function, how does it affect the graph? And then for h, we're going to see what happens when we subtract a positive number outside our basic graph, right? So these are outside manipulations where we add and subtract positive numbers, okay? So first, the suggestion is to make a table of values and graph the equations. So you have we chose several values of x, all right? You see the 0, plus or minus 1, they did plus or minus 3 and plus or minus 5. And then the basic function was absolute value of x. Let's go like this so we can kind of draw some attention a little bit, right? The basic function was absolute value of x. And then the first function in question was absolute value of x plus 2, right? So then the absolute value of -5, absolute value is just a positive distance away from 0, right? So the absolute value of -5 is 5. Absolute value of -3 is 3, 1, 0, 1, 3, and 5, okay? So that's just, absolute value is just a positive distance away from 0, okay? So then when we're gonna consider absolute value of x plus 2, we're basically just adding 2 to all the y values. So this plus 2 gives you this, plus 2, plus 2, plus 2, so on and so on, right? We're just adding 2 to all the y values, okay? So then the blue is the graph of absolute value of x. Can anybody describe what kind of manipulation did we do to go from the blue graph to get to the red graph? What did we do? What happened? What was the transformation that happened?
It went up the y-axis.
It went up along the y-axis. It went vertically up by how many units?
2.
2, right? So that brings us to our first transformation, right? So if we start with the basic function, if we add a positive number on the outside of our basic function, it moved the original graph up by that many number of units, right? And so outside manipulations tend to follow our intuition. So this whole section, I was trying not to show this. This whole section is, the concepts are simple, but it's, if you're not careful, it definitely can be information overload. We still got like a minute and a half, and I'll check attendance. But outside manipulations typically cause vertical changes, right? And they typically follow our intuition. So if adding a number on the outside causes it to go up, then the next logical flow is, what do you think happens if we subtract the positive on the outside? What do you anticipate happening?
Goes down.
You would anticipate it to go down, right? Let's see what happens. Let's see if it follows our intuition, right? So now we're starting with the same basic function, the same x's that we chose. We found the same corresponding y's. Now we're seeing what happens when we subtract a positive number on the outside of our basic function. So it's like basically we're saying each y value minus 3. So that gives you 2, subtracting 3 from all the y values. Okay. And sure enough, right, if the blue is where we started and the red is where we finished, notice it did indeed go down by that many number of units, right? So to kind of recap, these are the first 2 of like 8 transformations. I think it's 8. Outside manipulations typically cause a vertical change and follow our intuition. So if we add a positive number on the outside, it's going to go up. It's like adding y, adding to the y value. So it's going to go up that many number of units. Subtracting a positive on the outside is going to go down that many number of units. Outside follows our intuition and it's typically vertical. Okay. So now let's see what's next. So this is like a formal articulation of what we just said literally a few seconds ago, right? So C is some positive number, then the graph of our basic function plus that C is going to be the graph of our basic function shifted C units up. So again, if we add some positive on the outside of our basic function, it's going to shift the basic function's C units up. And if we subtract a positive number on the outside of our basic function, then it's going to shift our basic function C units down, right? So this is a more formal articulation of what we just said a moment ago, right? Okay. So adding on the outside goes up, subtracting on the outside goes down. Okay. So let's see what's going on here. Writing functions for horizontal shifts. So, okay. So now we're going to consider the basic function where we have f of x equals x squared. Can somebody tell me what should be the shape of this basic function? You know this. All right, what should be the shape?
The U.
It's a U-shaped graph, right? It's called what is it called? Begins with a P or a Q.
Parabola.
Parabola, and what's another name for it? Quadratic, right? So, but yeah, all of these are correct, right? So this is a U-shaped curve. It's also called a parabola, and this is called a quadratic function, right? These are synonymous. Now, so in the previous example, we saw what happens when we did manipulations outside our basic function. Now what we're doing are manipulations inside our basic functions, right? Okay, riddle me this. If outside manipulations cause the vertical change, what does your intuition say an inside manipulation might cause?
Horizontal.
Horizontal, right? Okay. I can get down with that. So we're anticipating an inside manipulation to cause a horizontal change. Now, only for the brave, what if you had to guess? Nothing's gonna happen if you're wrong. If you had to guess, what does your intuition say if you subtract the positive on the inside? Should it go in the positive direction or the negative direction? What do you think? What does your intuition say?
It go to the right.
To the right. Okay. So intuitively, right, because this is a -2, our intuition might say, oh, it might go in the negative x direction, which is to the left. But the gentleman just said that his intuition was saying, well, there's a lot of height, so maybe it's going to go to the right. So let's see what happens, right? So if we subtract a positive on the inside, we're going to see what happens, and we're going to see what happens when we add a positive on the inside. Now, the response was, his suggestion was, his intuition was saying to the right? Okay, so let's look at it. So we're basically going to repeat what we did before, make a table, choose several values of x. We're going to have our basic function, and then we're going to have this guy. Okay. So then we have several values of x. We have our basic function. And then, let's see. So then now when we do x minus 2, for instance, the first one, -4 minus 2 is going to be -6 squared. So that's where the 36 came from. And then we have -5 squared, and then the pattern picks up, right? So when we subtract it by 2, the y value still repeated, but the results were shifted down by 2 on this table, right? And something similar happens when we added 3 on the inside. Now let's plot these points and see how it affected our graph, okay? So I think his intuition was correct. But the whole point is, notice we started with the blue, right? You may be led to believe because we're subtracting a 2 on the inside, you might think it might go to the left, but in reality, it goes to the right. Inside manipulations cause a horizontal change, and they're typically the reverse of our intuition, right? Because -2 ended up going to the positive direction. So one way to kind of remember that or be aware of it, you kind of have to think about what value of x makes this 0. Since +2 makes this 0, this went to the right by 2. Since -3 makes this 0, we went to the left by 3, right? So inside manipulations typically cause a horizontal change and follow the reverse of our intuition. Like if I didn't hype it up so much, you may have been led to say this went to the left by 2. In reality, it goes to the right, right? So outside manipulations, so that brings us to a total of 4 transformations that we talked about so far, right? I think it's at least 8. It might be some more. But so to kind of recap, outside manipulations typically cause a vertical change and follow our intuition. Inside manipulations cause a horizontal change or are typically the reverse of our intuition. All right. Hopefully that's okay. Let's pause right there for a moment and let me check my attendance to see if we got some stragglers. We should, and we do. Okay, let me go like this, and let's get the stragglers right here. Thank you. Okay. Right here. Let's go here. Where is he? Right. Okay, there he is. I'm guessing this is okay. We just hit one. All right, I see. All right, so we should be good there. Looks like the stream is still healthy. Let's put the screen back. Okay. So, if you're just joining us, welcome. Hope you had a great weekend. We're going through the lecture for a section. This is 1.5 transformation of functions, right? So I think last week we focused on section 1.4, a library of basic functions. So we had this list of basic functions. I think together we made it through a few of them, but in the pre-recorded lecture, I think I'll go through all that entire section, right? So it's definitely a good idea to watch that lecture, take notes as if you're in class, right? Which you should be doing for all the sections, but you definitely might want to go through section 1.4. And then for today, we're going through section 1.5. We're taking that library of basic functions and we're talking about transformations of functions. And so we've already discussed 4 of the transformations. The first 2 were vertical transformations, where if we add or subtract a number on the outside of our basic function, it causes a vertical change. It follows our intuition. And then if we add or subtract a positive number on the inside of our basic function, it typically causes a horizontal change and is typically the reverse of our intuition, right? So those are the 4. Let's keep going forward and let's see what's next. Okay, so all 3 functions are squaring functions. Oh, okay. So this is kind of recapping what we just saw, right? So, if we have f of x equals x squared, when we subtracted the 2 on the inside, it was the reverse of our intuition and it made a horizontal change. It says the x-intercept of g is 2, right? So what value of x? X-intercept is the same as saying what value of x makes the inside 0, right? So the x-intercept is 2, right? So then we shifted the graph to the right by 2, right? So for each point x, y on the graph of f, there will be a corresponding point x plus 2, y on the graph of G. So the graph of G is the graph of F shifted 2 units to the right? Okay. So to go from F to G, we shifted to the right by 2. To go from F to H, we shifted to the left by 3, right? And it's a similar argument for this slide, okay? So that was just kind of recapping there. And this is a formal articulation of what we said, right? So let C be some positive number, then the graph y equals f of x minus c. Again, we're subtracting some positive number on the inside. It's going to be our basic function shifted c units to the right. So it's the reverse of our intuition. And then the graph of f of x plus c, notice we're adding the c inside our basic function. Then it's going to be our basic function shifted c units to the left, okay? So inside, some students often get tripped up by that. And the only way you really get a handle on it is through repetition. That's the way we get good at anything in life. It's through repetition. Whatever we practice, we'll get really, really good at, right? If we practice complaining, guilty. I'm the king of complaining and procrastination. I definitely have had my fair share of complaining, and I definitely have had my fair share of procrastination. None of that's... Only thing I found is that complaining, all it does, it doesn't really fix anything or solve anything. After I'm done complaining, the problem still persists. So for me to put a spin on the energy of complaining, what I did is like, okay, when I find myself complaining, that means, hey, this is just something that needs some attention. It's just an alert to me, like, hey, you need to go put that thing in order. Otherwise, it's going to keep distracting, right? So it's the biggest challenge there for me is just being aware that I'm complaining. And then the other thing with procrastination, I always get this sense of, damn it, if I had just started earlier, I wouldn't be so pressed and it would have turned out so much better, right? I do a decent job in procrastination, but I always do better when I start earlier, right? So long story short, whatever we practice, we will get really, really good at. So you want to at least at a minimum be proficient enough to get to this class. Now, I don't expect you guys to be mathematicians and to go out and create new theorems. I mean, you could. Stranger things have happened, but the way everything is set up right now, you got to take your time to process this information, get through it. When you get out of my class, that's not going to be the last time that you see it, but at least it won't block you. I even have a friend right now, she's applying to jobs, and half of these jobs, the first thing that they give her is a math exam. I mean, she's been graduated from college for a while. So, it doesn't stop, right? It doesn't stop. Just lean into it and keep moving. Okay, let's get back on track. So in this example, now we're going to be combining the vertical and horizontal shifts. So again, we've only talked about a total of 4, 2 verticals and 2 horizontals. So in this example, we're asked to sketch the graph of this function. Can anybody tell me what's the base function here? What's the basic function here that we're manipulating? What's the base function?
G of x equals the square root of x.
Right, just the square root of x, right? F of x equals square root of x. What does the graph of square root of x look like? We mentioned it at the start of class today.
Like half of a parabola on its side.
Right, so square root of x with no manipulations is if you took a U-shaped graph, turned it to the right, cut it in half horizontally, square root of x with no manipulation is going to look like the top half of a sideways parabola, right? So now we want to see doing multiple transformations in one equation one graph. So my experience with transformations, when you're doing these, especially when it's multiple, is you want to work your way from the inside to the out. So there are 2 transformations here. The innermost transformation is going to be this +2, right? So we just said inside manipulations, do they cause... What kind of change do they cause? Vertical or horizontal? So inside manipulations cause horizontal changes, right? So if this is going to cause a horizontal change, is it going to go to the right or to the left? Remember, inside is typically the reverse of our intuition. So should this go to the right, the positive x direction, or to the left, the negative x direction?
The left.
Should go to the left, right? Because the +2, you might be tempted to say, oh, it's going to go to the right, which is positive x. But no, inside is the reverse of our intuition. The x-intercept here would be what, -2, right? So this will go to the left by 2. Now, we have this -3 on the outside of our basic function. right? So if inside is vertical, then this -3 should cause, sorry, if this +2 is horizontal, then this -3 should be vertical, right? And if this is the reverse of our intuition, then this one should follow our intuition. So which way should that -3 go? You know it's vertical and it follows our intuition. So it should go down 3, right? So this is basically a story, right? This is a story. This is like an address, or it's giving you so much information. Notice we haven't plotted any points. We didn't choose any X values, find the corresponding Y's. We didn't have to break out no calculators or anything. This is a story. This is telling us a story. And I'm showing you how to translate this sentence. This is a sentence, right? So this is saying you have the top half of a sideways parabola, but then you move it to the left by 2 and down by 3. That's it. Let's do that one more time. We're considering the top half of a sideways parabola. We're moving it left by 2 and down by 3. So then you can like make a table and plot the points. You can choose several values of X, find the corresponding Y, and confirm those transformations. All right. Okay. Again, this section, the concepts are not difficult, but if you're not careful, you will definitely be overwhelmed. And it could be information overload. The only way I know to lessen that anxiety with the information overload is through repetition, right? To be honest, this kind of subject, like math in and of itself, honestly takes about 3 to 4 hours every day to get proficient by the end of the semester. It takes about 3 to 4 hours at least every day, right? That's just the honesty of it. I mean, it's always been like that. I just had a knack for it and I was enjoying it. I didn't have to engage people like that. It empowered me, right? Versus when it's like literature and stuff like that, there was always this argument and this back and forth. And it felt, a lot of times it felt like I was just losing just out of spite. Not that I was doing anything wrong. It's just that the professor or teacher just didn't like my energy. And they were like, I'm gonna give them this. And there was no real reason. I hated that feeling. I hated it. I was like, yo, that's bullshit. But in math, as long as my steps were justified, it empowered me, right? And that's why I fell in love with math. Okay, that's neither here nor there. All right, so our suggestion, our claim, we're saying that this should be the top half of the sideways parabola, that we moved left by 2 and down by 3. Okay, let's see what the prepared notes has. So they chose the basic function, right? Square root of x, f of x equals square root of x. And then they rewrote it as x minus like this. To me, that's like a little bit more confusing. I don't know why they would do it that way. But I guess when you write it as a minus, it makes it more clear as to which way you're going. And this one was, yeah, that's so weird. But anyway, we said left, right? So left by 2 and down by 3. So they're kind of putting it in like a standard form. So since C is negative, the graph is shifted horizontally 2 units to the left by 2. Right? So here's the top half of a sideways parabola. And we said first we went left by 2, and then we went down by 3, and then that's our final graph. Right? Okay. So they were basically putting the original function into this form. And then once you have your C, that tells you which way you're going. And then once you have your D, that tells you which way you're going. Okay. So, and again, you really don't get comfortable until you've done your own reps. You just have to kind of get reps in there. It is jarring initially. And see, we're only about halfway through. And the class is almost over, but we got a little bit of time, so we're going to keep going. So we've talked about 4 transformations so far. Now I'm considering, I don't know about on Wednesday, we can either continue with the lecture or we can go through the homework. We'll see where we stop today, and then we'll just kind of poll the audience and see how people feel. Also, as a reminder, so I have successfully created a Dropbox folder for like all these PDFs. So all the stuff that you see me writing, you can actually pull a copy of it from our Blackboard page. If you go to Blackboard and go to the link that says box link, you click on that link, and it's going to be folder number 2 that says notes. You'll find it in there. Just look for the notes section, and it's going to be there. But yeah, you actually have a copy of all the stuff that you see me writing for the entire semester. Additionally, I've went on and made a copy available for my other classes as well. So you can actually access the things that I was writing for the other classes. You can also watch my interactions with them also. So you not only have to watch yours, but like I have at least 2 other college algebra with lab courses, and I have a regular college algebra course without the lab, right? But you can watch any of those college algebra 1 courses. If you want to just get a jump on college algebra 2, you actually can access that as well. You can, that's on my channel as well. So if you are considering taking me for college algebra 2, you can honestly go ahead and study it in advance. And if you were to happen to get in my class, you'll at least be ready for it and you can kind of just get stuff done. Because usually what I do is make all the homework and quizzes available at the start of the semester. So if you finish your stuff early, then you'll just be waiting on the exams, right? Anyway, okay. So we got a solid 10 minutes. So this next set of transformations are reflections in the x-axis. So the graph of y equals negative f of x is a reflection of the graph of y equals f of x in the x-axis, right? So if you look at this basic function, it's like we went from a positive y to a negative y, right? So if y goes from positive to negative, that's flipping vertically over the x-axis. Remember what we said before? Outside manipulations typically cause a vertical change. It's like our y values are going from positive to negative. So it's flipping vertically over the x-axis, okay? So then if a point x comma y is on the graph of our basic function, then the point x comma negative y, notice the y's are going from positive to negative, is on the graph of this guy, okay? Let's see this in action, right? So say this is the original function in blue, then when we say negative f of x, it flips vertically over the x-axis, right? So notice the x values stay the same, but the y's went from positive to negative. Okay, so that's flipping vertically. So then if we can flip vertically, then we can also flip horizontally. Right now, earlier today, we said that horizontal manipulations typically come out of inside manipulations, right? So look here. Now, if we multiply the inside by a negative, it flips it horizontally over the y-axis. Let's say that one more time. If we multiply the inside by a negative, it flips horizontally over the y-axis. It's like our x are going from positive x to negative x. The y values are staying the same, but our x's are going from positive x to negative x. So if we have some point x comma y on the graph of our basic function, notice the x went from positive to negative for this guy. Okay. I know that's a bit much, so let's take a moment right there and let's just try another one. Let's look at the next part. Like just let that be, right? So say we were considering our original function in blue here. Then if we multiply the inside by a negative, notice the y values are staying the same, but now the x went from positive to negative. So it flipped horizontally over the y-axis. Let me just check my Zoom really quickly, just to see if we got any more stragglers. Oh, do we have quite a few? Okay. Let's go like this. So this is not one that you wanted to miss. It'll be late on. Thank you. Let me get these guys. All right. Who do we have? This one. We got 2 browns. I got this one. This one. JJ. There he is. And right here. Okay. All right. And let me check the chat really quickly. Okay. So there was a request. Before I do that, let me do this really quickly. Let's go here. We could do full screen. Let me just do a new slide. Let's log in. This one. I'll be right with you, gentlemen. We got a few minutes. Verify. Okay. Let me share my screen. So there was a request on how to find the PDFs. Let me check one more time. Chat. It's no worries. It's no worries. Better late than never. Okay. So and everything is recorded. You got your attendance credit, so it's all good. Okay. Let me show you how to find the PDFs. So if we go to our portal, I'm going to open up Blackboard, and I am going to go to our Blackboard page. So it is this one. So this is the landing page. Again, if anybody is curious as to hasn't found the lab for Alex, on the left-hand panel over here, it says Online Alex Lab. That's where you go for the lab. For our PDF notes, we're going to open up our folder. And then we're going to go to item number 4. Item number 3 that says Daily PowerPoint Lecture Slides. It says Box Link. So when you click on that, it's going to open up the Box app, right? So I already have the app installed. You might need to install the app or something or another. I can. Okay. There it is. So yeah, it should open up the app and then it should take you directly to this page, right? So basically what I did, since I have 4 sections of College Algebra 1, I just dumped all the College Algebra 1 stuff right here, right? So if you open up that folder number 0 that says syllabus, you can access the syllabus for any of my College Algebra 1s. And so our notes are here. So here you can find the student version. So the student version are like, it's like classwork or a worksheet, where basically it's the same as the notes, but I removed all the supporting details for the examples. So you have the original question for the example, and I would encourage you to try it out on your own initially. Like try to get as far in each section as you can on your own. And then once you get stuck, then you want to like watch the lecture. So that's the student version. You can find all of them there. And then the PDFs for our session is the first folder. And so this is basically like everything from all 4 of my College Algebra 1s. So, you see each week, right? And I have it labeled so you can find it. And it seems to be working okay. We officially kind of started on week 2. And so like, for instance, this is what week 6. So you have week 5, and then you have the times. All right. So you can find the PDF for you guys here. Am I missing something? 9 a.m. 4. Okay, it's fine. I don't know why that's in there like that. But that's fine. Yeah, but you can find the PDF here. Okay. Let's do a little bit more. Let's hang out for like about 5 more minutes. Let's try to get through these reflections. Okay. So now we're looking at, again, doing multiple transformations or combining transformations in one function. And again, the recommendation is when we're doing multiple transformations in one go, is to work your way from the inside to the out, right? So in this one, we're asked to explain how the graph of this can be obtained from the basic graph y equals the absolute value of x. Just for the sake of time, can anybody describe to me the shape of absolute value of x? I think we saw one today that kind of did that. What should be the shape of absolute value of x?
V.
It should be a V, right? So absolute value of x should be a V. Now, if we're working our way from the inside to the out, what's the innermost nested manipulation? If we're starting here, what's the first manipulation if we were starting from the inside? What's the innermost manipulation from here? What's the first one to consider? Or the one that's
-2.
-2, right? The -2 is the most nested, the one that's the furthest to the inside, the interior, right? So the innermost transformation is this -2. Inside transformations are typically cause a horizontal change and is the reverse of our intuition. So which way should this -2 move our V? So first, we have, absolute value of x is essentially a V, right? It's going to be a V. What does the -2 tell us to do? So it should be horizontal and the reverse of our intuition. So that -2, the -2 tells us to basically go, I'm trying to think of how to write it. It's telling us to go to the right by 2. All right, because basically the +2 is our x-intercept. So it goes to the right by 2. So then working our way from the inside to the out, can somebody identify what's the next one that we consider? If we've already done the -2, let's do the negative, right? So outside manipulations typically cause a vertical change. So this is like multiplying your y value by negative, right? So this is going to flip, we're out of time, over the x-axis. Right? So it's like the y is going from positive y to negative y because this minus is on the outside. We said outside manipulations typically cause a vertical change. Multiplying the outside by a negative causes it to flip over the x-axis. And then that plus 3 to tell us to go up 3 units. Okay. So this is what the sentence is saying. Start with a v at the origin. You go right 2 units, flip over the x-axis, and then go up 3 units. Okay, those are the transformations. And let me kind of highlight them like this. This will be it. 2 units to the right comes from here. Flip vertically over the x-axis comes from here. And then up 3 units comes from here. Okay. So then notice we started with a V. We went to the right by 2. And then we flipped vertically over the x-axis. And then we went up by 3, and the red is the final graph. Okay. All right. Are there any burning questions? You guys have any questions? Okay. Let me see, just as a quick short recap. Let me go ahead and load a copy of these notes. Thank you. I'm gonna send it to box. College Algebra 1. I think that looks good, but just to be on the safe side. Fall, College Algebra 1. This one, the notes, daily, right there. Cool. Okay. So when this bar finishes loading, you'll get a copy of what you saw me writing today and an official copy of the instructor notes. So you'll have all the details of each example. On Wednesday, we'll take a vote to see how you guys feel, to see if you want to continue going to the lecture or if you want to go to the homework. So we'll probably do a poll on Wednesday. If there aren't any burning questions, I think that's it. We're going to end the session here. And from one beautiful mind to another, stay dangerous, and peace.
Have a nice day.
Thank you, Professor.